Okay, so this is how you solve question number 21 in the book. This question asks, a soccer player kicks a rock horizontally off a 40-meter high cliff, and here's the sound of the fall 3 seconds later. What is the initial speed? Assume the sound of air is 343 meters per second. So, first we can draw this diagram. This is the cliff at 40 meters. It moves a position x and is launched at initial velocity of unknown. And it lands what is heard to be 3 seconds later. And the speed of sound is 343 meters per second. So we know the y value, so let's try and find what the actual change in time was. So change in y is equal to velocity times time. It's 1/2 gravity t squared. So 40 is equal to, since the initial velocity in the y direction is 0, that cancels out. 1/2 9.8 t squared. T is equal to 2.857 seconds. Now, that is different than this, because this is the sound heard, and we know that there's a difference between the time the sound was heard and the time it actually fell. So let's find the distance that was. So we can subtract 3 seconds minus 2.857 seconds and get 0.1428 seconds. That's the time it took to go from where it fell to the person that heard it. And then to find that distance, 343 meters per second, use dimensional analysis to find the total meters, and we get 49 meters. And so that's the time, that's the distance from here back to the person that heard it. Now, sound moves in a straight line, so we can make that the hypotenuse here and solve with x. So 49 squared is equal to 40 squared plus x squared. X will equal 28.3019 meters. Now, using x equation, we can find the initial velocity in the x direction. Change in x is equal to velocity times time. 28.3019 is equal to initial velocity times 2.857, and the initial velocity is equal to 9.906 meters per second.